So it seems like we have a new agentic framework join the party, PydanticAI. So what new features does it bring to the table? What is all the hype about? And more importantly, what can you build with it? Let's kick things off with a quick demo. This is what we're gonna try and build today. And while building it, I'll be exposing you to some of the best Pydantic features that I've come across and I can absolutely swear by. Okay, so what I have in front of you is essentially a task management app. So let's just run it. You can ask it questions like, give me all my tasks. Give me all my tasks. Now, it's gonna go ahead and try to identify what's the action I wanna do. So it figured out that, okay, I wanna get my tasks. Then it called a tool, which is gonna read from my database and it's gonna get all the tasks. And then it goes ahead and summarizes it for me. Wait a minute, I've already bought my groceries. I did, Mom, I promise. Now we're gonna fix it. Okay, so I already got all my groceries, Mom. Okay, so now the intent classifier has correctly identified that I want to mark a task as done. Sweet. But what just happened here? The model also figured out that the actual task to be marked as done is called buy groceries. And then it marked that task as done. Moreover, there could be so many different users in my system. So how does it know which user's task do we need to update? Wait, what the fuck am I talking about? Or shouldn't say that. What the hell am I talking about? Okay, Prasad, please make sure that you edit that part out, okay? Edit the swear words out. We can't do that. So what is Pydantic? Well, every framework usually has a thesis. It has some mindset that it's gonna revolve around. Pydantic is an agentic framework. Again, and I use the word agentic framework super loosely here. It's an agentic framework which revolves around type safety. Type safety is not the first thing that I reach for when I'm talking about LLMs, all right? But there is a lot of structured responses that we use, and technically I was using it all over the place, I just didn't realize it. And having type safety across the board and in the very fabric of how agents work, it changes certain things, okay? It changes the way you look at things. So just remember this, PydanticAI really drills heavy on the type safety. So we're gonna look at a couple of points which I think are really cool in Pydantic. The first one is structured responses. Very interesting stuff. How do you get structured responses from LLMs? Another one is their dependency injection system. I am not sure what I think about it, So let's try to form an opinion as we go through with it. These are like the most important things, and of course there's tool calling because every agent needs support to call tools some way. So we look at that as well. So there are three important things we're gonna look at. All the code is absolutely gonna be on GitHub. So what I have set up for you guys is a simple UV project. Like I said, the link is in the chat. You can just clone it up. It's completely fine. It's for you guys to play around with. So I've already set up what dependencies need to go in. There's a slim version of Pydantic as well, which you need to be aware of. But you know what? I'm just using the whole deal. I think it's just better. Now, one thing, if you do intend to clone this, you need to set up your OpenAI credentials. Now, I'm an open source guy. I always use open source. I think that's a well-established fact at this point. I am not using OpenAI. I'm using self-hosted OpenAI server. The models I'll be using is for models small. So I'm using Llama 3.18 billion for the small model. For medium, I'm using a Qwen 2.532 billion. If we are able to get high levels of consistency with what we're doing here, all right, we are getting it with really cheap, off-the-shelf, open weight models. That is just incredible. So that's what you need to set up. The next thing is you need to also set up your tasks. If you have multiple users, and we can even try it, like I can put in somebody else. So I have my task list, so that's my database. The name of the file is the user ID, okay? Just remember that. Of course, in your real world application, you might be using something like Postgres, or if you're the cool kid, you're using SQLite like me, you're gonna have a column like user ID. It's the same thing. It doesn't matter, okay? It's just JSON files because I was too lazy spinning up a database. Another thing is go through the README for sure, because all the commands that we available, it's all documented in the README. I'm using a tool called Logfire, which is Pydantic observability tool. We'll have a look at it. So the first thing, let's get introduced to Pydantic. Now, the way Pydantic essentially works is that it's very similar to LangChain in terms of the experience of setting certain things up. So I've imported something called the agent class, and I've also imported the OpenAI model class, right? So OpenAI model is actually the driver which talks to the OpenAI backend, right? That's basically what it does. And then you take the model and you just wrap it up in the agent class. Very similar to LangChain territory. I think this is the standard way most people do it these days, so there's nothing fancy going on here. But this is kind of annoying, right? Everybody is introducing their own abstractions. When I first saw this, I'm not gonna lie, I did get a little annoyed. Like, why another abstraction? I mean, you just created your own OpenAI model. Why not just use LangChain? Because LangChain already has so many things, just use that. But no. So it's kind of annoying. They have their own thing. It's not exactly compatible with LangChain. At least I couldn't make it work. But it turns out there's a reason for it. Okay, so let's just run it, you know? So what we're doing here is we're setting up OpenAI, and we're using model small, which is Llama 3.1, and we're just wrapping up with an agent. Now, to converse with the agent, you pretty much can do just one thing, is that you run or invoke the agent, right? A very interesting design decision Pydantic has made is that by default run is async. You have to be explicit to be synchronous, which makes a lot of sense. I think most of the agentic frameworks are IO heavy and they're going to be run in something like Fast API anyways. So defaulting to an async paradigm, I think that makes a lot of sense. I really like that decision. I respect it. Tiny things makes your life a better place. Tiny things makes the world a better place. Cool. So let's just run this. It's pretty straightforward. You know, we're just getting introduced. So 0, 0. Yep. There we go. So obviously the agent is not able to answer questions like what's my plan for today because it doesn't have any data. So yeah, we need to fix those things, which is fine. We'll fix them. But I want to take this opportunity to just go ahead and talk about this Logfire project. Logfire is Pydantic's Langsmith. I think that's the best way I can put it. Logfire is Pydantic's Langsmith. So we just ran a query, right? What it tells us is, so it shows me that, oh, you know what? There was a user message. There was no system message. So by default, there is no system message, which is kind of wild. User message, what's my plan for today? And what did the model give me as response? And I think the default sampling is 1. Every request is going to get sampled, which is good for development. But if you're shipping it to prod, you might want to tweak it. It's not super intuitive to use. You know, we'll get to Logfire later. How do you make a simple call with an agentic framework? I really like how clean the API is for simple things. Because not every task we're going to do is like the most complicated thing in the world. And a simple API is a good place to start. So structure responses. The first step that we had in our demo was identification of users' intent, right? Identification of users' intent. Now, technically, if you're doing any step like that, right? You want to do some kind of a routing step. If the user is trying to do this, then I want to do that. It would be amazing if I could just put a switch case on it. Right? That's how my mind works. Like if I want to do any kind of routing, just do a switch case. You'll have to make sure that you're getting the answer in some kind of a structured format. Or you don't want a sentence. You don't want to do crazy contains and things like that because that's not reliable. You want it to be structured. And Pydantic technically has you covered here. So what it does is it lets you build classes. So like I have an intent class with just one field called intent. Straightforward, I guess. And while defining the agent, you can also define that, hey, agent, whenever you give me a response, the type has to be intent, which is kind of limiting if you think about it, because what if you want like to balance between strings and classes and, you know, structured and unstructured? That's an opinionated design decision these guys have taken. If you want structured responses, you gotta specify it up front, and it literally changes the way processing happens within the agent. So it's not a superficial change, it's deep-seated, okay? It's very deep-seated. And then obviously you can have some retries because the model, especially open source models, might not be able to give the answer straight up in one shot. So you might want to like tweak things around. And this lets you do that. And obviously I've also specified a system prompt here. To identify the intent of a user's query, what we're doing is, hey, identify the user's intent, and the options available to you is get tasks, mark task as done, and add task. So I'm prompting the model in a very specific way to get one of these values. Models are known to misbehave. They kind of like me sometimes. I shouldn't have said that. Let's just run it and see how it works, right? Now it should work. So we're trying to do a structured response here. Okay, so it tried to make one step, but then it did 2 steps. Something happened. Just look at the Logfire logs, okay? It's saying preparing models and tools run step 1. So it's prompting it once. And then it says run step 2. So it's like prompting it the second time. I think let's go to Logfire for this. So if you look at the Logfire logs, I guess, this is what happened. So we put in the system prompt. Then we had the user prompt as well. That's the initial request that went in. The response we got was a tool call? What? Okay, something funny just happened here. We're calling a tool. This is a tool call. This is not LangChain. They have their own custom types. Calling a tool. And then it sends something like a retry because I think the model screwed up. Because the model responded with a tool call saying that, okay, you know what? Your tool name needs to be mark as done with no parameters. Wait, what? So it's like, I don't know any tool called mark as done. We only have one tool called final result. And then finally the model was like, I see what you mean. I'm going to call the tool final result. I'm gonna give it the parameters, and this parameter format is the shape of our class, the intent class. And finally, we have the final result, which says the result is processed. Do you see what just happened here? I know we are going deep into how Pydantic works. I'm just the kind of guy who likes to dive into the library and try to really understand what the hell, what the fish. Edit that part out again. So let's dive into a little bit of the code. Just a little bit of the code. Okay, we're going to dive into Pydantic. But okay, let's dive deeper into the library. We want to go to the OpenAI model, right? And then the OpenAI model return, this guy. So this is where the request to the OpenAI model is sent. I'm going to just add some logs here. So these are the messages which are going to go out. And I think this already tells you about Logfire. Like the fact that I need to do custom print statements within the library says that Logfire is probably not as descriptive as it needs to be. I think that's all I'm gonna say about Logfire. I am sorry, I know. I mean, these are new frameworks. It's gonna take time to mature. But this is my number one complaint. Logfire is not descriptive enough. But anyways, Pydantic is not about Logfire. Logfire is the observability tool, right? We can always just use our trusty old print lines. So I am just gonna log what messages were sent, what tools were sent. So the tools being sent are self.tools. Got it, self.tools. Okay, so if we run this again, the messages were, okay, first we get a system prompt, blah, blah, blah. Pretty long system prompt. Okay, we don't really need to get into all of it. And then it has my user message. I just got done with my groceries. And then it has this tools. So it's actually sending it a tool. And what's the tool? It's of type function because that's like the only kind of tool we support right now. The name of the tool is called final result. So it's a tool called final result. The description is the final response which ends with this conversation. And the parameters of that tool is nothing but the shape of the return type you want. What Pydantic is trying to do is tool calling is already a structured response format which every OpenAI compatible server supports. And Pydantic, instead of having its own custom prompts, instead of getting its own custom system prompt or instructions, it's just relying on the existing capability of tool calling. It's a really good decision because this means that there's no custom wizardry happening with your system and your user messages. They're sending the user and system messages as is. I have full control over those prompts. Now the bad thing is some structured responses might not be best suited for JSON because the way tool calling is implemented on most servers, the way I've implemented it on my server, it's through JSON, right? But sometimes you might want to use YAML because it's just more better suited for certain things. So it's a pro and con. It's just the way it is. So remember this, Pydantic is leveraging the tool calling capability of your inference server. So it's gonna act as a tool call and not as a custom message which Pydantic is then trying to shape up, right? It's a fundamentally different way than just calling an agent straight up. Sometimes your structured responses can be more convoluted. To represent complexity, I'm gonna make a typo, which is such a weird way of doing it. Typos is something open source models struggle with because they really want to correct that typo. What I'm gonna do now is I'm gonna say that, hey model, again, do the same thing, but now I have a typo in this. But again, I still want it that way, guys. I want the intent or the action to come back with the typo, but the model may have a tendency to correct it. At least Quen does. The model I'm using, it definitely does. Okay, so again, 2 prompts. Maybe the first prompt, the model did not respond in the right way, so it has to do another one. We got the intent as marked task is done. It took 2 prompts, which is fine. Sometimes it just takes a little bit of more time. Again, if you're using GPT, you're gonna be done in one shot, dude. It's pretty good. Quen struggles sometimes, but it gets the answer right. It's mostly because of this tool calling behavior, which I'll tell you how you can combat. I mean, I'll show you how I combated it. It improved the results remarkably. Because again, remember, open source models were not trained to do structured responses by tool calls. It just doesn't fit right? It's not how they're trained. The point is, the intent which we got back, it fixed the typo. That's a problem. We don't want that to happen. We want the typo. Pydantic gives us a very, very interesting feature. And I think this is what takes structured responses to the next level. The convenience and the opinionated way of doing it. What I can do is, against this agent, I can register a result validator. Okay, I'm not a Python guy, so I might be using the wrong terminology. I mean, I know this is a decorator, but this is how I think of it. Against this agent, I'm registering a result validator. So if you have a result, you can apply a result validator. And this will be called whenever Pydantic thinks or knows that the model has given the response in the right shape. So at this point, if this function was getting called, you absolutely know that the response was in the right shape. The contents could be wrong, but the shape is definitely right. And by shape, I mean schema. So what I'm going to do is, if the result.intent is not one of these, I'm going to ask the model to retry by raising an exception. This is a custom Pydantic exception. I can raise an exception to retry, and I can give it a very descriptive message saying that invalid intent provided. We want to make sure that the result is coming here. So we're doing an additional prompt to nudge the model a little bit more to get the right answer. Right? Result validator is not trying to work on the shape of the response, but rather it's trying to work on data contained within it. That's what we're doing here. Okay, let's run it again. Holy shit, it got it right in the first try. I want to make it fail. At least do a couple of retries, buddy. It just got stuck. Okay, got the right one. What was this retry? You know what? I should have put in a log here. I think that is one of the cons of Pydantic. It's very hard to know what is getting invoked when. So your debugging does take a little bit of a toll. If you go through their debugging documentation, it essentially says use logfile, which doesn't really do a great job. I think this is good enough. Let's run it one last time. If we get it, we get it. If not, I think you get the point though. Okay, validating intent. But you see, we got the wrong intent, so it tries again. And now we just got no clear intent. And now we finally got the answer. Takes a couple of tries. Come on, it's an open weight model. Now, if we go back to logfire and we look at this, it's gonna be a mess. But just bear with me. We start with the system prompt and the user message. Then we get a prompt saying, okay, this is the tool name we want to call. Again, it's not good. It's again structured responses with tool calls. It's a weird mix. You can fix it. Don't worry. I'll show you how to fix it, or at least make it work a little bit better. This is what Pydantic gives it upfront, right? That hey, weird tool call guy, fix it. And then it comes up with the right fix. It fixes it. But now our retry prompt goes in. So this is the one from our result validator. And we are like, hey, please choose from these. Then the model goes crazy. Then again, choose from these. And finally, we get the answer. Now, how many times this loop happens is dictated by this guy. So the retry interval is 3, right? So total of 4 prompts. Yeah, I think it's a total of 4 prompts. You guys with me? This is a really important point. This is one of the beauties of Pydantic. The opinionated way in which you can manage not just the shape of structured responses, but also the data is mind-blowing. Opinions are good. They help you build your application in a maintainable way. Because you would have to do this yourself. I'm not saying you cannot do it yourself. You could absolutely do it yourself. You're just reinventing the wheel, and you'll have to make sure that everybody on your team is using the same way. You'll have to document it, at which point you just created your own PydanticAI. Just use PydanticAI. But yeah, the tool call part, a little annoying. Keep that in mind. We'll get back to it. But dude, I'm in love with this. Honestly, I just love this. There's so many ways you can use this. And I know, Asha, you want to know how this compares to LangGraph and things like that. I actually wanted to do it as a separate stream, but we can touch it. You know, just like touch it and get back really quick. Next important feature, dependencies. Oh boy. Again, if you know LangGraph, it's kind of similar to the state object or the state that you pass in LangGraph. Remember when I spoke about the fact that I want to call a tool, so I want to read my tasks, But reading a task requires the user ID. But I don't want the model, or I don't want to expose the user ID to the model. Normally what would happen is you would have to tell the model that, hey, you know what, I have a user, he has this user ID, these are my tools, and then you form the parameters which need to be passed to this tool. And because user ID is one of the parameters of that tool, the model would have to know about the user ID. You want to get rid of that. You don't want to do it. That's where dependencies comes in. Okay, this is one of the use cases, okay? Privacy, I don't know what to call it. You know what, let's just look at it. Again, you define a shape for your dependencies, so it's a class. The reason I made it a data class is so that I can create an object from it really easily. I don't need to make that init and all those crazy things. So it's a data class. I have my agent, and this time I'm specifying that, you know what, my dependency is of this class. This is my dependency. Now we registered something new. I'm just trying to show you as many features of Pydantic as quickly as possible. What am I doing here? This is a static system prompt, but sometimes you want a dynamic system prompt. You want your system prompt to be customizable. So what would you do in a tool like LangChain? Well, you would have made a system message and dynamically based on some parameter value, which is kind of a leaky abstraction because you'll have to make your own custom function which creates that system message, and then you pass it to the LangGraph model while invoking the model. It's a leaky abstraction, right? You're kind of adding your own layer on top of LangChain. This guy doesn't work that way. This guy is trying to contain that. So what it's doing is it's saying that, okay, you know what? You want to dynamically generate a system prompt? Sure, you can do that. It's given me a function, and this is called the context. This is the context of execution. So here, whenever you prompt an agent, the variables which are associated with that prompt and that prompt alone, so it's not associated with the agent, it's associated with that prompt, that's the context. And in the context, because we specified my dependency type, you're gonna get the context of that type. And now you can simply use the variables within that class or within that object to build your system prompt. And now the way the system prompt registration hook or decorator, whatever it's called, the way it works is it's gonna take this and it's just gonna add it to this system prompt. Every system prompt function that you define, you can define multiple. They each simply get appended to the static system prompt. So if you had no system prompt, this would be the only system prompt. So what I'm doing here is, you are a helpful AI assistant. That is gonna be my static part of the system prompt. Always use the user's name in the response, and the user's name that will be dynamically added to the system prompt when I invoke the agent. And while invoke the agent, this time I need to provide it the dependency. Specifying the dependency while invoking the agent, I gave it my name. I mean, this guy gets invoked. I'm using the name to populate the system prompt, and then it gets added to this, and then the actual prompt, the actual inference call is made. Okay, so we run the agent and it used my name this time. How did it work? If we go back to Logfire, it seems like it sent two system prompts, but you see the second one has come right here, and then comes my user message. So the final prompt which is sent to the model, it contains the new system prompt as well, which is really good because this means that you can pass around dynamic system prompts, or you can pass dynamic values in the system prompt while invoking things. So if this was part of a REST API, you could have used some values coming from the database dynamically and injected into the system prompt. It's very useful. I'll tell you why we need it. We're gonna need this where the correction happened with the title thingy, like where we figure out the right title. That's where we actually need it. But the best part is the context is available to use in tools as well. So when you're actually calling a tool, you could say that some of the tool's parameters could come from my context and some could come from the model. So the model doesn't need to know every parameter which the tool really needs. It just needs to know the available parameters or the parameters that you can expose to the model. The remaining parameters could come from your dependencies. Very important concept. Meanwhile, I really need to see whether it's actually sent to system prompts or not. I'm sorry, my mind is stuck there because that's crazy. That's absolutely wild if it did that. It actually sent it to system prompts. Oh my god. Oh my god. That is insane. I don't like that. Okay, I don't like this. I'm gonna raise an issue for this. I really don't like this. They should be appending it to the same system prompt. There shouldn't be two system prompts. Some models can go absolutely nuts if it gets two system prompts, guys. This shouldn't be happening. Calling tools is very similar to how you would do other things, especially structured responses. You always define an agent. Everything in Pydantic revolves around calling an agent. I've got a system prompt right here, but I do have this additional part in the system prompt, like don't call the function if you already have the task. We'll see why I added it. It's weird. And then To register a tool, you do it in a very similar way than how you would do it for LangChain, wherein you just say agent. So it's agent.tool and you just have your task. So it's very similar to LangChain. I think LangChain has an @tool decorator, but yeah, this is agent.tool instead. Now the difference here is that using this decorator will directly bind this tool to the agent. So it's not in the global space, it's directly bound to the agent, which is good. One less step for us. Now the interesting part is, look at the parameter definition. So the first one is the context object. The model has no idea that this tool is going to be accepting a context object. That is something Pydantic takes care of. Whatever comes after the context object, that is something which the model will have to decide on. So the context object is Pydantic scope, it's a contextual information, and anything else is decided by the model. So since we want to get the task, we want to filter like what kind of task do we want. So we want the model to be able to decide that based on the user's query. And the dependency thing which we just spoke about earlier, that is visible here. So if I had a dependency, I could have used that dependency over here. So if I was calling like a database function and my dependency had a user ID, I could have used that user ID to call that function. And we'll see an example of that as well, which is really cool. Now, if you don't want this context object, like technically I don't need the context object here. So there's another decorator called tool plane. And if you do that, you can just omit the context object completely. So tool plane is essentially the tool without the context. But if you want the context, use tool. I just think we should use tool because it's explicit and you know that there's a context object right there, even if you don't use it. Like you can always like put an underscore in front of it. Oh, underscores don't work in Python. Okay, whatever, it doesn't matter. On purpose, I'm just returning a string here, but okay, you could do a database call or whatever. You prompt the agent just like you would normally do, but you don't need to worry about whether there are some tools registered or not. It's a clean abstraction. I really like it. Let's run this. Cool. So we run the prompt. What's my plan for today? So of course, it's going to prompt the model. The model did decide that we want to invoke a tool. The tool get tasks, but it seems like it prompted the model again. So after running the tool, it seems like it prompted the model again. And this is like the weird behavior of Pydantic tool calling. Let's go to Logfire. So if you go to Logfire and we check out what happened, you can see that, okay, we started with the system prompt, we went with the user prompt, that's good. And then it decided to call the task and it's just trying to get the pending task. Another request was made where Pydantic essentially gave the model the value returned by the tool itself. LangChain does not do this. So if you bind tools to LangChain models and then you invoke them, if there's a tool call, LangChain won't even invoke the tool for you. LangGraph won't even invoke the tool for you. This not only invoked the tool on our behalf, it also did an additional prompt giving it the response back. And based on my experience, and I've actually gone through the code, what is happening here is it will keep prompting the model till the model finally takes a decision that I don't want to make any tool calls. This is very annoying. This is super annoying. I mean, try to understand what's happening here. Pydantic, the agent, will keep calling the model till the model takes a decision. I don't have any more tool calls to do. This is another cognitive decision, another reasoning step the model needs to be. I don't even think 8 billion parameter models can take that kind of decisioning, because think about it this way. The model already needs to decide on what tool to call with what parameters. That's a hard task by itself. Most models cannot do that once the number of tools goes past 5, especially the 8 billion parameter models. Now you're adding another layer wherein the model first has to decide whether you want to call a tool or you don't want to call a tool. If you want to call a tool, what's the parameters? Not great for open source. Again, GPT can nail it down every single time. Sonnet, sure, can nail it down every single time. They struggle with this. And that's the reason why. That is the reason why I added this extra prompt. Now, there is an issue which I opened with them. There is an active task where they want to end the result based on the tool call. So the tool can basically decide that, you know what, please don't go to the model again. Since I've been invoked, that's end of story. It's not merged yet though. So that's where the hack comes in. The hack which, you've been seeing, which, I keep commenting and then uncommenting and stuff like that. This one right here. Yeah, I had to dig into the code and understand how it handles structured responses. So structured responses, like I said, it's nothing but tool calls. And what it does is whenever you're processing a structured response, especially a tool call, it will never finalize the result because the result can only get finalized after, like when you don't have a structured response, or you have a structured response with the result schema. It's complicated. Let's not get into it. What I did was I essentially just tricked Pydantic into thinking that, I'm marking the result as done myself. And whatever the tool returned me, that's gonna be the final value. So it's always gonna be string. So I kind of violated their type safety, which is not good. And I passed in the tool name as well. But again, I'm only doing it for the tools which have task in their name. Not the cleanest approach, but they're gonna fix this. They are definitely gonna fix this. If you use Pydantic as of today, and that PR doesn't get merged, whenever you call a tool, Pydantic, the agent is going to prompt the model again and again till it gets a string response. So the model will have to like conclude that tool call somehow. I don't like it. It's kind of annoying. It is what it is, guys. It is what it is. Yeah, but that's tool calling. Now we want to get to the final demo. What Pydantic does additional is it can even do streaming structure responses, which is pretty cool. So if you have like an array of objects being returned, you can stream those responses back and, you know, populate your UI as those objects come in, which is pretty dope if you ask me. It's pretty cool. It uses like partial something of Pydantic, and that's how it works. Again, I didn't test it out. I think it's a cool feature, but you can try it for yourself. Now let's go over to architecting our final solution. So we're going to make a workflow. We start the workflow and we end the workflow. So we start and stop. So we're going to make a workflow. Think of it like a flow of a function, right? It's supposed to be top to bottom. I like to do it left to right. I don't know. I'm weird. So there are 3 tasks that our final product needs to work. Our final demo is essentially a task assistant app, which can help you read your tasks. So it can tell you what your tasks are left. It can mark tasks as done, and it can add new tasks, right? So let's start with the easiest one, which is adding tasks. So obviously we'll need an agent which can do add task. We need a query as well. This is going to be the user's query. What's going to happen is we are going to start by asking the user for a query, and that right now we can just do add task. Okay, we're going to incrementally build it. So we'll simply ask the agent to invoke the tool add task, and it can straight up add it. Before any of this, while starting, we'll also need the user's ID. So that's a dependency. We'll have a dependency called user ID. We'll just take it up front. Technically, you would get the user ID through your authorization, which happens in your endpoint or something like that. But now I'm just going to hard code user ID up front. So we know that the CLI is always going to talk with this. I mean, it's always going to be this particular user for that CLI. You know how to get the user ID, right? I mean, just do an authentication or something like that and get the user ID. So we have a dependency called user ID, and then we'll ask the user for a query. And the agent will just have add task, and that's pretty straightforward. Now let's say we want to add another feature. We want to add the feature of reading tasks. Well, that shouldn't be too hard either. The same agent can be given 2 tools, I guess. This should work, right? Give the agent both the tools. I think the model would be smart enough to figure out that based on the query, whether you want to read tasks or you want to add tasks. However, I was also summarizing the tasks in case of read tasks. So technically, if you were using a good model, you could write the system prompt in a way that, hey, if there was a read task, then make sure you always summarize it towards the end. Because remember, Pydantic kind of prompts the model again after a tool call, right? So you could technically use that for summarization. I'm going to stick with that for now. Now comes the tricky piece, marking a task as done. Now, if your instinct was to add yet another tool here, this is not going to work. This is not going to work. Okay, why not? It's not going to work because the query may not reference the task in the same way as it was mentioned in the database. The user might use, I don't know, might just structure the sentence in a different way. So if your agent tries to add that task, it's going to be a little tricky. I mean, technically, you could make the tool in a way that it uses AI to first figure out the title and then call it. I just think that's a little convoluted. I usually don't like to do anything AI related in my tools. I want my tools to be deterministic. So the way I would do this is essentially, I would introduce a new agent here. And this agent would be an intent classifier. This would be an intent classifier. Okay? So this guy essentially decides whether the user wants to add a task, read a task, or mark a task as done. So essentially I introduce a router, LLM based router. So this is going to tell me whether it's a read task. Now technically I can separate out my agents as well. So I could just do read. If it was a write, I could have done a write. Because I've already separated out my read and write, I could potentially even add another agent for my summarization part, for my smaller models, right? We go easy on the small models, guys. We go easy on the little guys. So I could just add another agent for summarization. Read and write, figure out. So we have an intent classifier. So at this point, these don't even need to be agents. If it's a read, you can just call the tool directly, right? Because read might not require any parameters. I'm still making it an agent. The reason why I'm doing that is because the intent might not contain all the parameters. Like while reading, you might need a filter or some additional parameters that needs to be decoded. So I'm still gonna make it an agent. And even though I've made it like separate blocks, I do wanna highlight, these could be a single agent, the same agent. These could be the same agent. I'm just making it separate, signify the different tool calls. So you know what? I'm just gonna call it tool. We're gonna call it the executor agent, because that's what I've called it in the code base. Now the question is, how do we solve that mark as done? Because remember, the user's query might not describe the task the same way it's in the database. What we need to do here is essentially add another step. If the intent was to mark a task as done, we do a title extraction. So we have an agent whose sole responsibility would be to identify what's the right title. To achieve this, yes, it would definitely need access to the database. It's not doing a tool call. Again, it's not doing a tool call. It needs access to a database or read task, right? So it's technically doing a read tasks, but not as a tool, because it needs to know what tasks are there in order to figure out whether there's a title which is similar to the user's query or not, right? So it's not a tool call. And once we've identified the right thing, that's when we can say mark done. And this too can simply go in here. Does it make sense? A little bit? Let's run through this again. We start with the dependency of the user ID. We then ask for the query. Then we try to identify what's the user's intent. Based on the intent, if it was read, we simply go to the executor agent and we trust that the executor agent will call the read task and they will call the summarizer. Pretty straightforward, nothing fancy. If the intent was right, again, we go to the executor agent, but this time we trust that the executor agent will call the right task tool. We straight up ended, we don't need to summarize that result. And finally, if it was supposed to be, we were supposed to mark a task as done, we could essentially go to another agent whose sole purpose would be to identify the title. Once we've identified the title, then go to the executor agent, and the executor agent can use that information to mark the task as done, and then we end it again. Let's try to implement this. How does this look like? So first, let's look at our agents. You know what? I'm gonna collapse this. Let's go with the intent classifier. Again, I'm using a medium model, so it's a 32 billion because classifying intents is a hard problem. It requires reasoning. Anything that requires reasoning, you cannot work with an 8 billion. That's just my experience, right? So we're using structured responses, which again, remember, is technically a tool call under the hood, which is annoying, right? Models get that wrong. And we are explicitly specifying that if the user mentions that they've done something, mark the task as done, action will be invalid for all invalid messages. Now, remember I said that because it's a tool call, it does something funny and the model kind of get confused. And you saw that happen when we were doing the structured responses demo as well, right? The model was not able to call the right tool. We kept seeing that again and again and again, right? We kept seeing that. One way to solve that problem is taking control of the tool's name. Let me go over to Logfire. I'm actually using Logfire a lot. You know what? I think I was a little hard on it. I am using it a lot. So it's maybe it's not that bad. But okay, let's go to intent classifier. So this is what what normally happens with structured responses in Pydantic. The problem was, whenever we are doing a tool call, the tool's name is called final result. And that description of the tool is just give me the final result based on the conversation. This is not in line with what the model really has to do. I mean, there's no correlation between final result and a user's intent. And that is why the model sometimes just goofed up and, it did not call the tool right. So the way I solved it was taking control of the tool name. So instead of calling it final result, I'm going to call it user intent. So it's not called final result, it's called user intent because that's exactly what we're trying to do, user's intent. So now we have a correlation between the tool name and the job to be done. Next, in the description, I'm making it seem that the model needs to log the user's intent. So the way I've crafted this agent is that, hey, you know what? You're not actually giving me a response. You are like a logging tool. I'm giving you a query and log the user's intent somewhere. So you need to call the tool to finish this. So the way the agent has been crafted is keeping in mind that, okay, you know what, this is actually a tool call. Drafting the tool name and the description in a way that the model thinks that it's actually supposed to call the tool. This makes the cognitive reasoning process a little bit easier, at least in my testing. If you take control of the result tool name and you give a description as if it needs to log the output, it gets it right most of the times, guys. I mean, I'm really impressed and happy with the result. I'm not gonna lie. And obviously, I have my custom result validator as well, that if you give me an action which is not something I want, I'm gonna retry. Make the model go again and be like, hey, give me a proper intent, bro. What are you doing? So that's our intent classifier. Next, let's have a look at the title extractor, because I think that's what most people are interested in. Ashaya says, it seems to be on par with most of the observability tools anyways. See, Ashaya, the thing is, I come from a DevOps background. I come from a cloud background, right? I'm not an AI guy. Observability for applications is like at its peak at this point. It's so good. Coming to observability of this standard, it breaks my heart. It really breaks my heart. So I think my standard for observability is just a little bit too high, and the AI folks, maybe they don't dabble with observability that much. I don't know. This is how we did intent classification. Now let's move on to the next thing, which is the title matcher, the interesting stuff, the magic, right? The way we actually figure out what title actually needs to be updated or marked as done. This is the agent. We have a system prompt, straightforward. You are a helpful AI assistant. But here I have dependencies. I've got a dependency, and that dependency is user ID. I'm going to need the user ID now. Model doesn't need to know the user ID. That's confidential. I don't want to share it with the model. So I'm going to keep it with myself, and that's why I put it in the dependency. I do want a result type. So I want structure response. Again, the structure response, I want a title, like what's the identified title, and also tell me if the title was present or not, because it is possible, guys. It is possible. The user might give me something which is not there in the database at all. I've registered that system prompt handler. So I have a dynamic system prompt. But what do I do here? What do I do in this system prompt generator? I am reading the task from the database. Read task is essentially my tool, which goes ahead and, reads the database and gets me the value. And it needs a user ID, right? It needs a user ID. I'm getting that user ID from the dependency. So now I have a list of all the tasks for that user. And then I'm adding a system prompt. And what am I doing? Identify the title provided by the user. The title must be present in this list. And I give it the list. The list is a YAML formatted string of all the tasks. Find the title which is the closest match to the user's input. If no title is present, provide an empty string and mark is title present as false. Is title present was the response we wanted. So I am literally making a tool call, which is not a tool call. I am manually making that call. It's not an AI decision. It's a human decision. It's a system decision. It's a programmer's decision. So the programmer has decided, I have decided that I will get all the tasks, shove it in the system prompt, and that will give the AI enough context to make the decision whether I have the right title or not. It's such an elegant way to do this. There is a lack of flexibility which comes with this approach, but I think I'm fine with that. But okay, the executor is something very straightforward. It's like, hey, you're a helpful AI assistant. Follow the entire conversation history carefully to identify the tool to call and pass parameters to them. Basic prompt engineering, so that we nudge the model to make the tool call and call the right tool. And of course, do not call the function if the action is already performed, because I was just testing without that hack, and I wasn't getting good results. It works, but it's not super reliable. And then again, I have all my tools right here. I'm using the context this time, which is my user state. I passed it here. So I get the ID. And then the read task requires no arguments from the model, but it requires a model to pass to my function. So I simply take it from the dependencies. So the model doesn't even know that this tool has a parameter. That's so cool. I love this. This is just so convenient and so elegant. And I have another tool called add task. Here the model needs to decide the title, but the user ID is going to come from the context. And that's what I've done right here. And similarly, I have mark is done. The title is going to come from the model and the ID is going to come from the context. And that's what I've done here. I don't like to make my tools indeterministic. Like I said earlier, you could have made this tool to make an AI call and figure out the title and things like that. I want my tools to be deterministic. That's an opinion I stick with. Once you reach the tool call phase, you need to have the peace of mind that, okay, if you call the tool, it's always going to work, right? You need to have a deterministic separation from your indeterministic side of things, right? There needs to be a bound somewhere, and for me, it's tool calls. I know anything inside tool calls, it's going to be normal Python code. It's procedural. I don't have to worry about things messing up here as long as the parameters are right. Talking about parameters are right, we raised that model retry exception. You could have raised that exception here as well. So essentially, you could have done something like if ABC in title, then value error, as in this tool will throw an error. Or you could even do a model retry. That, hey, you know what, you did not generate the title properly, recall this tool. So the tool can have some sanity checks baked in to nudge the model into calling it with the right parameters. This is so elegant. This is so beautiful. I love this. Oh, and yeah, we have the summarizer. Pretty straightforward. Just summarize, nothing fancy. So these are our individual agents. And you see how I've written the code, right? Each agent is nothing but a file. And just the way the decorators work, all I need to do is import this agent and everything will be with it. And because it has a first class concept of dependencies, I don't even need to worry about, making a function which templates the system prompt and things like that. I just have to import the agent and just call run invoke on it. That's it. That's a very clean abstraction. I create my state. I create my dependency object. Like I said, I'm just hard coding my user ID right now. Then we ask the user for a query. Then the first thing we do is identify the intent. Now, because we're using structured responses and Pydantic, like I said, it's type safe. There you go. My LSP can figure out that, okay, action data is not a string. It's of type intent. So, okay, we got the result. And because we have the result validation steps, I can be at peace that this action is going to be in the format I want. We are not solving the problem of indeterminism, but at least we don't have to worry about the shape and schema errors anymore. I can be assured that, okay, I've got an action, and if my system prompt was written in the right way, this action is always going to be one of these 3 or 4 things. I can just do a switch case, like I said. If the case was add tasks, I'm just going to take my task executor agent and I'm going to run it. But this time, I don't need to give it the user's query. Because I already know this is like an add task, I can straight up give it a custom query and say that, you know what, identify the right title and add the task. This makes sure that the agent will call the right tool, because your query is more nuanced, right? Okay, and if it was get task, we simply tell the agent to get the task. Ideally, you would want to pass the query here as well. But since we have no parameters in the get task tool, we don't care, right? We can just make our custom thing. And obviously, because it was get task, we want to summarize as well. So I simply call summarize. That's pretty much it. And I can have my custom instruction here. So mark task as done. Then I call my title matcher agent. And I can simply give it the final title. So instead of giving it the title or the query which the user originally gave it, because I have this intent classification done, I can craft my own instruction and only give it relevant context. Now, this is really important. You'll often hear in the AI world that, you know what, context is king. You need to make sure that you have all context, but you also have to make sure it's relevant context. In this example, the query itself was not relevant. So when you're trying to mark a task as done, the query itself is not relevant. Why? Because like I said, the phrasing of the title might not match with what's in the database. So from the model's perspective, that's misleading. By preparing a custom instruction and passing the final title as a part of the instruction, we are making it easier for the model to make the right decision. So it does not need to know what the original query was. This is an opinion. This is not something specific to Pydantic. This is just how I do things. I think working with models has tuned my brain to work in a certain way. I look at these models as my little kids who are absolutely useless, and I have to make their lives as easy as possible. Otherwise, they just won't work. I don't have kids. I don't know why I keep bringing that up. Oh my God. I don't know what's wrong with me. And finally, we print the title. Pretty good, right? We're gonna run the final script one last time, I guess. We can give it a query. What query should we give it? Let's start with get the task. Get the tasks. You can see that the intent classifier kicks in. In one shot, it figured out what the intent is. Then we go to the task executor agent and we give it a custom prompt and it returned all the tasks. And finally, we go to the summarizer, which is this boy. It summarized things for us. Really cool, right? Alka, you had asked a question that did we screw up structured responses to fix the bug in tools? No, we did not. We absolutely did not. Because you see, structured responses is still working. Remember, intent classifier is a structured response. It still works. And now if you want to mark the task as done, I walked the hell out of that dog. It clearly identified that the intent is to mark a task as done because I'm giving it a statement on something I've already done, right? And there you go. It figured out that the title is supposed to be walk the dog and it marked the task as done. I can try to answer the question of, do I need Pydantic or should I use something else? What would you recommend? Let's try to answer that question. Now, I know you guys might not have complete visibility on a tool called LangGraph. So far, it's been my favorite agentic framework, but I want to point certain things out. This is a fairly easy workflow. Like the diagram is right here. It's very hard to figure out what the flow is by reading this code unless you pay attention to it. Because you'll have to figure out that, oh, there's an intent classifier, it's going to give me an action, and then based on that action, then I'm going to be an add task that calls only one agent, but get tasks, it's going to call two agents. Oopsie. Mark task is done, it's also going to call two agents. Oh, you know what? Mark task is done, it's also throwing an exception. You'll have to go through the entire file in order to figure out what is happening. This is a feature, not a bug. When Pydantic says control flow and agent composition is done with vanilla Python, this is what they mean by it. This is vanilla Python. Switch cases, if else's, vanilla Python. That's what they're talking about here. For easy workflows, I think I'd prefer this. It's still easier to write. It's vanilla Python. It's good. But as your workflows start getting a little bit more complex, that's where things start getting a little weird. And that's where representing your workflow as a graph is going to be better. Visualizing your workflow like this would be better, right? The more complex your workflow, visualizing as a graph would be better. LangGraph was made with this in mind. Whenever you make any workflow with LangGraph, it's going to construct a diagram like this one for you. That's out of the box. It just works that way. How does it work that way? Because every step is essentially a node in LangGraph, and then you connect the various nodes by means of edges. Like you're saying, I start and then I give it to the identifier agent. And then whenever the identifier agent is done, I go to a conditional edge. What is that conditional edge? It's either gonna say end or it's gonna go to the next node, which is find matching agent. Again, you don't have to worry about these things. It's gonna literally generate a graph which looks like this. So for more complex workflows, LangGraph, I think it's a more maintainable way to write code. You can achieve the same functionality with Pydantic, with LangGraph, or just raw dogging the OpenAI SDK. It's all about the mindset and the problem you're trying to solve. Pydantic is focusing heavily on how should we interact with the concept of an agent. And it's come up with an opinion that the way you interact with the agent is just by calling run sync. End of story. No matter how complicated your agent is, at the end of the day, it's just going to be a run sync. Pydantic has no opinion on how you orchestrate those agents or design a workflow from those agents. You use vanilla Python. I was gonna say TypeScript. I was gonna say vanilla TypeScript. I think people would ban me if I would say that. Do join my Discord. I have a lot of cool stuff going on in there, especially what's coming up next. I have some plans to use Discord to try to create this community of talking about agents and talking about AI and all these cool stuff. So we'd love to see you there. That would be absolutely amazing. I have created a channel called Stream Ideas Hub. Please suggest what you would like me to cover next. So head over to Discord. Once again, thank you so much for being here. I know we went way above our limit. My editor is going to have an absolute nightmare editing this one. Like, share, and subscribe if you found this video to be helpful. And don't forget, I am your tech bot. You're on YouTube and hopefully in real life.